So if you did not turn in problems 1 through 8 from the algebra review that you see here, please make sure you've done that. Today we're going to focus on problems 9 through 12, okay? And we're going to kind of keep breaking it down each day. So you'll notice I've highlighted problems 9 through 12. So let's go ahead and take a look at those. Now, problems for 9 and 10, both of those are just taking algebraic expressions and adding, subtracting, multiplying, dividing. Just remembering, well, no division, just multiplying. Do you know those rules? Okay. So the first one there, number 9, let me give you some hints. Make sure that you distribute that negative first, and then you're going to combine like terms. Distribute that negative first, combine like terms. Here, you're using the distributive property to each thing. Your power is going to be going, your x's are going to be going up by 1. But I want to focus on D. We'll do D together. So whatever I don't do, you're going to get finished on your own, okay? So let's look at 9D. If we think about order of operations, we're going to go to the innermost parenthesis and ask ourselves, is there anything we can do? There's nothing we can do in that parenthesis, but this we can. There's not much we can do. There's a plus between them. So if we distribute a positive 1, that doesn't change anything. So really what we're looking for in here is, are there any like terms that we can combine? So the 1 and the negative 4 are the only like terms there. So I'm going to just write this. There's nothing in front of it. That's not touching another parenthesis. So the parentheses themselves are irrelevant. But this one, we do need that parentheses once we combine like terms. Get in the habit of writing things in descending order. It's helpful, especially if you go further in your math. Just get in that habit. So we've got y squared plus 3y. The plus 1 and the minus 4 is a total of negative 3. To continue the process, the only thing left before we do our final combining of like terms is to distribute that negative. So let's go ahead and do that. So we're left with y cubed plus 1 minus y squared minus 3y plus 3. Okay. This time we still only have like terms for the constants, the plus 1 and the plus 3. I'm going to rewrite it in descending order. Again, it's a good idea to do that. So our final answer would be y cubed minus y squared minus 3y plus 4. Okay. So those are just, simplify as much as you can, get it to where you can, and then you're done. Okay. So please, it is your responsibility to finish number 9. Now I'd like to talk about 10. For 10, problem A and B, hopefully you just recognize that that's just a FOIL. Distribute the x to both of those, distribute the 5, combine your like terms. So I think A and B are not a problem for you to do on your own. I would like to do C and D. Let's first concentrate on C. It doesn't matter how many terms we have. If 2 parentheses are touching, we're going to distribute all the pieces of the one to the pieces of the other. So the first thing we're going to do, let's distribute the x to all of those. So we're going to multiply that second parenthesis by x. So that's going to be 2x cubed plus 3x squared minus x. Now I have to distribute the positive 3 to all of those. When I do that, I get plus 6x squared plus 9x minus 3. Okay. Now, again, you should get in the habit of going in descending order. The x squareds are like terms. Combine those. The plain old x's are like terms. So our final answer for 10C would be 2x cubed plus 9x squared plus 8x minus 3. Now, because I just don't have enough room, let's talk about D and E, but I'm going to do E for you. D you can do on your own. My hint for D and E, because of the squared there, a lot of people make a mistake that they don't FOIL that properly. So please make sure that you write it twice. So then you remember that you got to FOIL it. You got to distribute. You got to do all that stuff. So continue D. I haven't done it. Again, I didn't give myself enough room. But I am going to do E with you right now. So we're going to write it twice. We're going to write it twice so that we remember that we need to distribute. Okay, so let's go ahead and distribute. We're going to distribute the 5 to both pieces. We're going to distribute the negative 9x to both pieces. We're going to get a list, put it in descending order. We're good to go. If we distribute the 5 to both things, we get 25 minus 45x. If we distribute the negative 9x to both things, we get negative 45x plus 81x squared. And then again, my suggestion would be always get in the habit of putting your final answer in descending order. It's not a big deal. If you wrote your answer in a different order than me, it's still the right answer, but it is helpful when we go to do other things, or if you go into calculus, it's just helpful. So our final answer would be 81x squared minus 90x plus 25. So please finish 9 and 10. Do we have any questions about either 9 or 10? Do we have any questions about 9 or 10? Everybody good with 9 and 10? Okay. Now, 11 is going to go backwards. Now, when I scanned this, there were some little stuff there. Not that those things are not right, they are, but I'd like to explain them, so I'm just going to kind of scribble those out for a minute. Okay, let's take a look at factorization. I'm going to give you some hints as we go through factoring. We've done factoring and we've talked about it from the start, but I just want to remind you of some things. The first thing you should always look for, is there a greatest common factor that you can take out? Do that first. Always do that first. That's always your first step. Second thing you want to do is whatever is left, how many terms is it? If it's 2 terms, is it a squared minus b squared? Can you do something with it? Is it a cubed minus b cubed? Is it a cubed plus b cubed? So if it's 2 terms, it might be a pattern, okay? If it's 3 terms, can you unfoil it? Can you unfoil it? That's what you would look for. If it's 4 terms, can you do grouping? So I always kind of count the terms. If it's 2 terms, is it a formula I can use? Is it 3 terms? Can I unfoil it? If it's 4 terms, can I do grouping? And then the third thing I always do is I check again. Because sometimes you'll get a new thing in a parenthesis that actually can factor one more time. So I always check again, okay? So anytime I factor, and I've been teaching factoring and algebra for a long, long time, that's the way I always do my factoring, and then it usually works pretty good. So is there a greatest common factor I can take out? How many terms is left in my parenthesis if I took out something? If it's 2 terms, it might be a formula. If it's 3 terms, I can unfoil it maybe. If it's 4 terms, is it grouping? And then once I get some parentheses, can I do it again? Okay. So let's focus on a few of these. We're going to do quite a bit of 11 together. Okay. So in A here, the first thing I noticed is they both contain an x. You can always remove the lowest power. So we can remove an x squared. If we remove an x squared, I'm left with x minus 1. So do you see how I took out a greatest common factor? I have it in parentheses an x minus 1. I always ask myself, is it something I can go further? Well, x minus 1 is done. It's factored as far as you could possibly go. Now, B and C, we're looking to see if it can unfoil. It's 3 terms. There's no greatest common factor. So we jump right to, hey, 3 terms, can it unfoil? Can it do one of these kind of things? That's kind of what we're looking for there, okay? Now, B is, what are the factors of 1? 1 and 1. Do they add up to 2? Yes. So that means it's factorable. So that's just x minus 1 and x minus 1. Now, if you want to write that as x minus 1 squared, go for it. You don't have to, but you can, okay? Let's take a look at the number 8. The factors of 8 are 8 and 1, which subtract and give you 7, and 4 and 2, which subtract and give you 2. This one is what we call a prime. It can't factor, not in any traditional way. So you can't do a darn thing about number C. It is factored as far as it can go. It's a prime factorization. Let's take a look at D. D, does anybody notice, is there a greatest common factor for D that we can remove? 4. Yeah, so we can take out a 2. Do they all contain x's? Yep. What's the lowest power we see? Yeah, just an x to the first. So we're going to take out a 2 and we're going to take out an x first. Okay. Now, when I take out a 2x, I am going to write this final thing in that descending order. It's super important. It's super helpful. So our highest power was, actually, I'm going to take out a negative. Now, I don't do that often, but I take out a negative when my highest powered term, the x cubed, is negative. It does help the whole process. So let's take a negative 2x out of everything. Then we're left with x squared minus x minus 2. So what did we do? We took out our greatest common factor. And you can check if we distribute. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative x is positive 2x squared. Negative 2x times negative 2 is positive 4x. So you kind of check your work. Okay. What's interesting about this one is that I never give myself a lot of room on these, but we can actually factor that x squared minus x minus 2 one more time. The factors of 2 are 2 and 1, have a difference of 1, so it'd be x minus 2 and x plus 1. Okay. So that would be your final answer for number 11D. Okay. 11E is kind of an interesting case. Way I think about it is I've got stuff squared minus a perfect square. It actually is the formula. You might not see it, but it's actually the formula a squared minus b squared. You can take the square roots of each piece and put a plus between them and a minus between them. Okay, but it's kind of weird because it has a parenthesis there, but it still has a squared on it. So think of it as stuff squared, and then just keep that stuff there when we square root it. And so first off, it's going to look weird, but let me show you. It's going to be our stuff minus the square root of 2x, our stuff plus the square root of 2x. And does any of those factor? Yeah. I'm sorry, we don't have a lot of room. So that's what you get initially. Is it in descending order? It's not. Let's put it in descending order. Both of those things factor. Your final answer, just for room's sake, this one would break down into 2 things and be x minus 1 squared. This one would break down to 2 things and it'd be x plus 1 squared. So that's a funky one. So that is 11E. Okay, so first it's stuff minus 2x, stuff plus 2x. Put it in order. so that you can see, does it factor, and it actually does factor. It's a weird one. Okay. Before I want to do F and G, I want to do H and I with you. So can we do H and I, please? H, there's no greatest common factor. That's a very good candidate. I've talked to you about something called slide and divide. You can do guess and check. You can do asterisk. There's all these methods but I'm going to take the 3 and I'm going to scooch it over there and I'm going to multiply it by the 6. I'm going to pretend like my problem is, x squared plus 7x minus 18. Okay. Now that is something, it factors very quickly, very nicely. 9 times 2 is 18. 9 and 2 have a difference of the 7 I'm looking for. It factors very nicely. So it's just x plus 9 and x minus 2. So that's the beauty of slide and divide. We slide it over, we do the factorization, but what did we slide over? We slid over a 3. So to take care of the fact that we multiplied by 3, now we're going to divide by 3. And so we're going to divide both of these pieces right here by 3. If it divides by 3, divide it. So 9 divisible by 3. So that becomes x plus 3. But the 2 does not divide by 3. So to fix that, we're going to put the 3 denominator on the x. And so it's 3x minus 2. And that's our factorization. That's our answer. That is how that right there factors. So it's x plus 3 and 3x minus 2. Kind of an interesting one, okay? Let's do I together. Remember, is there a greatest common factor? Remove it. After you remove it, can you factor what's left? Okay, that's what we're going to do for problem 11I. Okay. I am going to take out a fraction, which is a weird thing to do, okay? But I'm going to take out a 1/3, and I'm going to take out an x. Now, the reason I'm going to do that is because it's really hard to factor with a fraction involved. So if we take it out, to divide by a fraction of 1/3 is the same as multiplying by the reciprocal of 1/3, or just multiply everything by 3. When you do that, you get x squared minus 9x plus 18. Well, we kind of had this 18 happen before. 18 is 9 times 2. That doesn't make the 9 we need. 18 is 18 times 1. That doesn't make the 9 we need. But 18 is 6 times 3, right? 6 times 3 does add up to the 9 we want. So this is going to be x minus 3 and x minus 6. 3 times 6 is the 18 we want. 3 plus 6 is the 9 we want. If the back sign is positive, the middle sign repeats in both parentheses. If the back sign is positive, the middle sign repeats in both parentheses. So the only ones left of these to do, I still want to do them together. I want to do F and G together. But I need a little bit of room. I've run out of room, so I'm gonna add a page so we don't have to squish it. Okay, so let's do 11, F and G. Okay, let me just copy this, okay. So, okay, let's talk about my factoring kind of little template I told you about, okay. So I told you, always look for a greatest common factor. Once we do that, count how many terms it is, okay. F, there is no greatest common factor. It is not in descending order. It is in ascending order. The powers are going up. But if it's 4 terms, I don't really care because some patterns actually occur with 4 terms that are good anyway. Do you see how it goes 9, -1, 9, -1? That's good. The powers are all going in the correct order. That's good. Because we're going to do a method for F. We're going to do what I call grouping. Okay. I'm going to group these two together and these two together. Okay. And you're going to remove a greatest common factor. If there isn't one, you put a 1 there, just kind of as a little placeholder. So those first two pieces, well, they don't have anything in common. That's in the case, we're going to put a 1 there. Okay, so we're going to take out a 1. Sometimes when that x is negative, I'll take out a -1. That sometimes will fix some things that occur later on. And here, I'm going to take out, they both have an x in common. So if they have nothing in common in grouping, take out a 1. If they have an x in common, take out an x. Now we know we are correct. Oh, actually, we can take out an x squared. Sorry about that. We can take out an x squared. The lowest power is an x squared for those two. Okay. Now we know we're correct if these two match. Okay. So think about this is the stuff that match. That is the stuff we're going to take out. That's our greatest common factor. So we're going to take out a 9 minus x. Now what's left when we do that? Well, we took out the 9 minus x here, so we're left with a 1. We took out the 9 minus x here, so we're left with a plus x squared. Now, okay, let's go over the rules I talked about. 1, greatest common factor, take it out. If there isn't one, how many terms does it have? If there's 4 terms, do grouping, which we just did. But the last thing I said was always check, can I factor again? If this were a minus, if it was 1 minus x squared, it could factor again. But 1 plus x squared, the sum of squares cannot factor again without using like eyes or funky things. So we're done. That one's done. Okay. So F is done, but now let's talk about G. Now, G is in descending order. There are some patterns there. The patterns aren't as obvious as the last one we did, but I see plus, plus, minus, minus. That's a good pattern. I see big, little. That's a pattern. There are patterns there. Okay. We are still going to group these two together and these two together. Oh, I'm sorry. That was an x cubed. This one's a cube. Okay. For the first two terms, the only thing they have in common is an x. The lowest power is an x squared. Take it out. The last term, they have a negative in common. They're both divisible by 25. Take out a negative 25. Okay. So we're looking at 2 terms at a time. What do those 2 terms have in them? Okay. So if we take out an x squared from the first 2 terms, we're left with a 5x plus 1. If we take a negative 25 out of the back 2 terms, we're left with a 5x plus 1. Now you can check by doing distribution again. You better get what was sitting on the page. In my parentheses, do I see the same thing? Do I see the same thing in both parentheses? Yes, that means my grouping method worked. Because now I'm going to take out the 5x plus 1. Now what's left when I do that? Well, the x squared is left for the front. The negative 25 is left in the back. Now, again, let's go over those steps. Greatest common factor, remove it. How many terms? Try that method. The last thing I said was look again. Is there something that can factor now again? Yes. Our x squared minus 25 is the difference of squares. It can factor one more time. So that's why you never completely stop until you look one more time and go, can I factor one more time? And you can. So your final answer would be 5x plus 1. These 2 pieces factor again using our difference of squares. X plus 5, x minus 5. In any order, it doesn't matter. So that is the factoring section. If you recall, factoring can be difficult. I don't expect that it still wouldn't be. Even when my students get to calculus, we still kind of review our factoring rules one more time. And you know, factoring will come up in any algebra course or any calculus course if you take it in the future. It's not going anywhere. Okay. We won't use factoring quite as much the second semester because we're going to deal with trigonometry stuff, but factoring still does come up, especially difference of squares. That comes up quite a bit. Okay. So 11 now is done. Let's talk about 12. Let's talk about 12. So for problem number 12, it says to write the expression in simplest form. Don't worry about the fact that y cannot equal -5. That just means, remember, we can't have a zero denominator. They're just saying, hey, don't worry, y is not going to equal -5. Y squared minus 25 is a factorable quantity. How does that factor? How does y squared minus 25 factor? Difference of squares, Anthony. How do you factor that? You got it. Okay. Because these are perfect matches, they have to be perfect entire matches. You may cancel them out. The answer is y minus 5. That's it. That's all they wanted you to do there. Okay. So 11 or 12 was wonderful. So there's only a few more left that we didn't do together for problems 9 through 12. For the remainder of class, finish those up. Don't forget the problems or the assignments that are up on the chalkboard. 6A notes, 6A homework, 6B transformations, December achieve. All those things are going on the next 9 weeks. So if you turned in problems 1 through 8 yesterday, 9 through 12 today, check those other things in Google Classroom. Did you turn them in? They will go on the next 9 weeks. Okay, so there you go. Just work for the rest of class.